Good morning, students. In the last class, we discussed about the genesis of the periodic table. In that, the four laws are there. Among those four laws, we studied law of triads as well as law of octaves. Okay, so in the today's class, again I explained the Mendeleev's law also, but today in this class, I'll elaborately explain what is that Mendeleev's law, what is studied, everything. Okay. So students, as I told you, law of triads means that is proposed. This law is proposed by the scientist Dobermeyer. Okay, at that time 31 laws, sorry, 31 elements are known. In that, he tried to arrange them in the increasing order of their atomic mass. So he successfully arranged only 9 elements. So he fails to explain remaining elements. What is law of triads? The atomic mass of the middle element is the average atomic mass of the first and last element. Okay. So next one is Newland's octaves law, or law of octaves if called. Okay. So what is that law of octaves states? So he tried to arrange the elements of set 8. Okay, so he said when you try to arrange the elements in the increasing order of atomic masses, the first and the eighth elements resembles with each other. Means they show similar properties. The first and the eighth element. This law is proposed by what? Newland, Alexander Newland. Okay. So the next one law is that is Mendeleev's periodic law. So before explaining this Mendeleev periodic law, I'll say simultaneously two scientists keep on work on the periodic table. Okay. So first scientist Lothar Meyer, another one is Mendeleev, Dmitri Mendeleev. Okay. So these two scientists worked on periodic table same time. Okay. He tried to arrange the atoms in the increasing order of their atomic mass only. Okay. Both of them try to arrange the elements in the increasing order of their atomic masses, means mass number. But what he did, he tried to draw a graph of atomic mass versus atomic volume, or atomic volume or density. Okay, so this type of under melting point. Okay, so you try to draw a graph for a physical properties like atomic volume, density, and melting point with respect to atomic mass. So this fellow tried to arrange the chemical properties and physical properties both. He tried to arrange a graph only for the physical properties. He tried to arrange the graph according to which physical as well as chemical properties with respect to what? Atomic mass. So when both of them try to draw the graph, this fellow get variation in graphs. Okay, but this fellow get increase in graph. Understand? Means the same properties like atomic mass, if it is in the increasing order 1, 2, 3, 4, 5, 6 is there. So keep on checking these chemical properties. The species which comes under the same period and the same group shows the same type of properties. Understand? So here, listen, I will give one example. For example, lithium is there, sodium is there, potassium is there. All are belongs to same property. So here atomic mass is 6, here it is 23, here it is 39. Okay? Not 39. This one is 39. So students here, assume, but these all shows what chemical properties of M X compounds. For example, X is a halogen or a Cl you assume, it forms LiCl, NaCl, KCl. Property is same, correct? So atomic mass increases. This is 6, this is 23, this is 39 you assume, then the chemical property remains same. Understand? By observing the graphs of physical property as well as chemical property, we try to arrange the species which are showing same type of properties in the same column. Understand? So this Lothar Meyer successfully explained only this type of graph up to calcium, that is already explained by Newland. Up to calcium, you learned already successfully explain what happens, right? So that's why this Lothar-Meyer theory was discarded, and this Dimitri Mendeleev's theory is elaborately explains the physical and chemical properties of the elements. So this theory is accepted because both the scientists worked on the periodic table at the same time. But this theory is most elaborated than Lothar-Meyer theory. That's why this theory is discarded. This is accepted, and this Mendeleev is called as a father of modern periodic table. Why? Because he is the scientist who gave a key point for the synthesis of the modern periodic table. What he said? So listen, according to this Mendeleev, okay. So students, according to this Mendeleev, the statement, what is the Mendeleev's periodic law is the properties of the elements. The properties of the elements are the periodic function of their atomic masses. This is a statement of the Mendeleev's periodic law. What it is? The properties of the elements are the periodic functions of their atomic masses. Means in the periodic table, when you try to arrange the physical and chemical properties are based on what? Their atomic masses. Understand? So what he did first? He tried to arrange the species with the chemical properties and the physical properties in the same groups. Understand? So in the table, he made this type of 9 columns, that is vertical columns, okay, and horizontal rows 7. Okay, he prepared a table with 7 horizontal rows and 9 vertical columns. And those 9 vertical columns are called as groups, and this 7 horizontal rows are called as series. Understand? Okay, completely. Okay, so this is the table. So students, the name the columns in the Roman letter like 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, we call these columns as groups. Okay, groups. Okay, we call these vertical columns as groups and these horizontal rows. How many? 1, 2, 3, 4, 5, 6, 7. As what? Series. Okay, this is one more important question. What are called as groups? What are called as series? The horizontal rows are called as series. The vertical columns are called as groups. Total 9 groups are there and 7 series are there in Mendeleev's periodic table. So he tried to arrange the elements in the increasing order of atomic masses. So when he tried to arrange, here in the first group, he got noble gases. In the 0th group, he got noble gases. In first group, alkali metals means it's block elements. Okay, next alkaline metal. Here it is, as I told you, okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Here it comes helium and neon. Understand? He kept the zero group elements in the first row, first column of the periodic table, followed by the next elements. Understand? Next, so after this, students, here argon will come, followed by potassium. Okay, but atomic mass of argon is 40, atomic mass of potassium is 39. Okay, atomic mass of argon is 40, atomic mass of potassium is 39. So as we try to arrange the elements in the increasing order of atomic masses, according to that, potassium should come first, followed by argon. But here, argon comes first, followed by potassium. So he fails to explain why argon is not kept first. Understand? So because as I told you, we try to arrange the elements in what? Increasing order of the atomic mass. Here masses are then 39 will come first, next is 49. So sorry, 40. So here potassium is 39, argon is 40, even though he kept the argon in the first element, as the first element. Understand? He fails to explain. So when he observes this, then he start ignoring the atomic weight. Okay. Next, he considered purely the physical and chemical properties. Understand? When you understand these two, he ignored the arrangement of the elements in the increasing order of atomic mass, and he tried to arrange the elements in the based on same physical and chemical properties. So then he got so many elements arranging in a different manner. And at the same time, students, here carbon is there, silicon is there, and next elements are there. So he left gap here. In the arrangement, he left gap here. And at the same time, after boron, aluminium is there. Again for a next element, he left gap. Means at that time, these two elements are not yet discovered, but he predicted there may be a possibility of two extra elements there which were not yet discovered. So he already predicted when he forming the table. So he left gap here. So those gaps are called as eka silicon and eka aluminium. Okay, he called those elements as what? Eka silicon and eka aluminium. So eka silicon means it is later discovered as germanium. Eka aluminium means later discovered as what? Gallium. Okay, students. So what he predicted? So listen, he predicted that atomic mass of this eka silicon is 68. Atomic mass. Germanium atomic mass is 70. He predicted eka aluminium mass is 72. So this one 68. This one is 70. So he predicted eka silicon as 72. Eka germanium is 72.5. So approximately same. He predicted the values when framing the periodic table. You understand? Okay. So the first thing is he tried to arrange the elements in the increasing order of atomic mass. Okay. Next, he tried to arrange the elements in the based on say physical and chemical properties. Okay. And he left some spaces for the undiscovered elements like eka silicon and eka aluminium. So this periodic table clearly gives an elaborate idea about the classification of element, and it is most justified answer he gave. Okay, that's why this theory is accepted. Okay, until the Henry Moseley, at the year 1918, he suggested a modern periodic law. He proposed a modern periodic law. Until we are following this Mendel's periodic law. Understand? So he is the key scientist which give an elaborate idea to frame the modern periodic table. Okay. Now what we are using is the modern periodic table with 180 elements. Okay. So students, this is all about the Mendel's periodic table. So why this law is discarded? Please listen. So you know, hydrogen has three types of isotopes. Correct? Hydrogen has three isotopes: protium, tritium, deuterium. Right? So protium, deuterium, tritium. So next, carbon also carbon isotope C12, C13, C14. So C12 and C14 isotopes. Okay. Here 6. So here this is atomic mass, correct? Right? So 1, 2, 3 are the atomic masses, 12 and 14 are the atomic masses. These are atomic numbers. So Mendeleev try to write the atomic mass, elements in the increasing order of atomic mass. But in this table, he never give a place for isotopes because isotopes are the species having same molecular form, same atomic number, different atomic mass. Atomic year 12 is there, year 14 is there. So according to this law, you should give a place for these two isotopes also. So here it is 12 is there, 14 is there. Both are having the different atomic masses, correct? Even though he considered only one carbon here. He didn't assign a proper positions for the isotopes based on their atomic masses. Okay, and he fails to explain why he is not able to assign the places for atomic mass. So isotopes, even though they have a different atomic masses. Understand? So the Mendeleev's periodic table, there is no place for isotopes. At the same time, he fails to explain why potassium, argon comes first, followed by potassium. Understand? So because of all these drawbacks, this theory is discarded, and then finally we are following the modern periodic table. Understand? So this is all about the Mendeleev's periodic table. The thing you have to remember here is what is Eka silicon, what is Eka aluminum, what are groups, what are series. Okay, that much is enough. Okay, next one is modern periodic law. So this is this law was proposed by Henry Moseley in the year 1918. Okay, students. So here listen. He considered the properties of the elements are the periodic function of their atomic masses. This is what Mendeleev's periodic table. Only the thing changes is it is the periodic function of atomic number. Understand? The the properties of the elements are the periodic function of the atomic number. That is the just correction of the Mendeleev's periodic table. He did just this thing only. Okay, he considered atomic number instead of atomic mass. So why not this Mendeleev consider this atomic mass? Why he considered this atomic number means because atom consists of the subatomic particles like protons, neutrons, and electrons. At the time when Mendeleev discovered the periodic table, they don't know about the subatomic particles. There is a protons, there is a neutron, there is an electron. They don't have idea about that. Understand? So that's why it's considered only atomic mass. So after in the year 1918, all the subatomic particles are discovered by Dalton, okay, Chadwick, okay. They discovered Rutherford, all are discovered proton, neutrons, and electrons. So he got an elaborate idea about the framing of the periodic table. So what he did, he tried to draw the graph for the atomic number versus the properties. Okay, so your atomic number is there, increasing order 1, 2, 3, 4. I will take atomic number. Here properties. Okay, then it got a straight graph without any variations. Understand? That means as the atomic number increases, either the property increases or the property decreases. We got a straight line. There is no variations in the lines or the graph. Understand? So that means he understood that in a subatomic particle or particles or atoms, the atomic number is the fundamental property than atomic mass. Understand? Atomic number is the fundamental property than atomic mass. Understand? So from that what he said, so he proposed that the properties of the elements are the periodic functions of the atomic number, not atomic mass. So then, when he got this idea, he keep on arranging the elements on the basis of atomic number. He got total vertical columns right here. Okay, friends, this is the representation of the present form of the periodic table what we are using in nowadays. Okay. So here we try to arrange the elements in the increasing order of atomic number, means here start from 1, 2, 3, 4, 5, 6. We started arranging, correct? So here hydrogen is there, here helium is there, here lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Correct? So if we study the properties of the elements along the group, along the period, everything we got in a perfect manner as he explained. So along the period, so listen, if the atomic size we consider, okay, this is 1, 2, sorry, 1, 2, 3, 4, 5, okay. So listen, I consider atomic number from the second element, 3, 4, 5, 6, 7 from here. Understand? So students, as the atomic number increases, size decreases along the period. That means the size keep on decreasing. So if you consider atomic number along groups like sodium, potassium, rubidium, cesium. Okay, so hydrogen is 1, lithium is 3, this one is 11, this one is 9. That is atomic number. So if you consider the students, then the size goes on increases. So along the period, the size decreases, along the group size increases. Understand? So not only for this, you may observe this for each and every row and each and every column. So here boron, aluminium, gallium, helium, thallium is there. Those also must decrease, increase in atomic masses. Understand? So that means along the group, all the elements show same type of properties. That's what he explained. Understand? When you try to arrange the elements in the increasing order of atomic mass, they are arranged in such a way that the species which are showing the same chemical and physical properties, they are arranged in the same. This is from 58 to 71. This one is from 90 to 100. 92, 10. These are F block elements, but they are present in the D block element. Understand? To represent the periodic table, if we insert these 14 elements here, means it will much elaborate. Understand? These F block elements is present in the P block element, sorry, D block element. That's why these are called as inner transition elements. I'll explain this later, students. What are these elements? These are called as pictogens, halogens. Okay, and this one is called as chalcogens. These are called as other gases. These called as alkali metals, alkali metals. Why they are called like so? I'll explain later. Okay. So now you consider only they have 18 vertical columns and 1, 2, 3, 4, 5, 6, 7. Okay. 7 horizontal rows. So here the 18 vertical columns are called as groups and 7 vertical columns, sorry, horizontal rows are called as periods. Understand? So in the modern periodic table, vertical columns are called as groups only, horizontal rows are called as periods instead of series. Understand? So here, again, listen. Here, if they try to arrange the elements in the form of in the increasing order of atomic number means there is no need to explain the space for the isotopes. Understand? It successfully explains the why the place of so there is no place for isotopes in the periodic table. Okay, and he successfully explained why these left in the why these helium, neon, and that means noble gases shows the end of the periodic table means because their valency is 0. They show completely filled configuration. So the completely filled configuration means that ends the periodic table. Understand? The next term listen. 1s1, 1s2. Again start from 2s, 2p, 2p6 starts from 3s. This shows what? The end of the configuration. Correct? 2s 2p MCL means things start from 3. 3s 3p MCL means start from 4. 4s 4p6 MCL means start from 5. So these noble gas configuration shows complete filled configuration. To show the complete configuration or a complete of the periodic table, they placed at the extreme right of the periodic table. Understand? And another one, listen, in the left hand side, whatever the present species are there, those are metals. In the right hand side, if you keep on moving, these are what? Non-metals. Understand? So in the periodic table, as we move from left to right, the metallic character decreases. Non-metallic character increases. Because listen, they are purely metals starting from here. But here boron, carbon, nitrogen, oxygen, they are not metals, they are non-metals. So boron is metal. Carbon, nitrogen, oxygen, chlorine and neon, those are all what? Non-metal. So in the periodic table, in the left side only metals are there, right side of the periodic table non-metals are there. So from left to right, the non-metallic character increases, metallic character decreases. Okay. So again, we classify them as here S block elements, here they are P block element, this is D block, this one is F block. We classify the elements in the different block also. S block, P block, D block and F block. How we classify them? Why this lithium belongs to only S block? Why this lutetium? Okay, lutetium. This lanthanum. Okay, RCO. Okay. Why lutetium belongs to F block only? And this scandium means why it is belongs to D block only. Here boron carbon means why it is belongs to P block. Even though why it is belongs to only 14, like that he explained. So on basis of what? Like SPDF means listen. If we consider any atomic number, if you try to arrange write the electronic configuration for the respective element. So here listen. Hydrogen, lithium, sodium, and hydrogen atomic number is 1, configuration is 1s1. Correct? Lithium atomic number is 3, configuration is 1s2, 2s1. So sodium atomic number is 11, configuration is 1s2, 2s2, 2p6, 3s1. So here what we are going to see students, the last electron of the element enters into S subshell. The last, the valence electron of the element enters into or ends up with S subshell. That means that belongs to S block. Understand? That's why they belongs to S block. If you consider second, 1s1 is there, means at the first position. Here, first. Here it is S1, here S2, this is D1, D2, D3 up to D10, this is P1 to P6. Understand? Next listen. If you consider this one, beryllium. So beryllium, magnesium, calcium. Okay, beryllium atomic number is 4, magnesium atomic number is 12, this calcium atomic number is 20. Okay, if you write the configuration, it will get 1s2, 2s2. Here 1s2, 2s2, 2p6, 3s2. Correct? Here 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Understand? So here the ends will got 3s2, 2s2, 3s2, 4s2. That means they belongs to this beryllium, magnesium, calcium, strontium, barium, radium. Understand? So we successfully explained why the elements are in the same group. Not only this, if you take this scandium students, after this 3D orbital will come. After 4s, 3D orbital will come. Understand? Why that will come? I will explain in the atomic structure chapter. Okay? Because some rules are there to write the electronic configuration of the species. In that rule, before 3D orbital, 4s orbital fill up takes place, followed by the 3D orbital, next 4p. Why? I will explain in the atomic structure chapter. Okay? So this is all about the periodic table. So here you consider boron. Boron is atomic number 5. If you write the configuration, 1s2, 2s2, 2p1 means the last electron enters the p block means it is a p orbital. It belongs to p block element. Understand? This is what is successfully explained about the classification of the elements. So here S block is there, P block is there, D block and F block. Understand? So here remember one thing. S block has 2 columns, that is 1 and 2. P block has 6 columns, start from group 13 to group 18. Okay? D block elements have 10 columns, so that is 3 to 12. Okay? F block elements 14 students. There is no column here. There is no columns for the number here. It has a 14 columns only. Understand? Like this, there is no column number. They considered as series. This is 4F. This is 5F. Okay? 4F series and 5F series they have, not groups. So D and F block elements are studied in series, not in groups. Later I will explain why in the properties. Okay? This is only about the periodic table. While explaining the properties of the elements in the periodic table, I will explain details. Understand? So this is the periodic table what we are using in today's era. That is the modern periodic table suggested by what? Andreas Moseley in the year 1918. So what is this modern periodic law? The properties of the elements are the periodic functions of the atomic number. So I try to arrange the elements in this, then we got this. So students, they may ask the question, which one is the period with the less number of elements, or which one is the incomplete period, which one is a big period, like that they may ask. So listen, this one, the first period, only 2 elements are there. So first period is smallest period. Okay, first period is smallest period. Next year, 6 and 7 periods are longest periods. Okay. So next one, which one is incomplete means 7th period is incomplete. Or then ask which one is the longest period means you may write 7th period. Only 7th. And it is the incomplete period. Why listen? Here the element 118 is there, correct? If 118 element is there, we don't know whether 119 element is there or not. Why this periodic table stops here means still At this, only the elements are known. Listen, only 118 elements are known. That's why the periodic table is still 118 elements. We don't know 119 element is present or not. So they are not yet discovered, I think so. Understand? That's why this period is an incomplete period, as I consider there may be a chance of existence of the elements greater than atomic number 118. Understand? So this period is the longest period. This is the shortest period. Understand? So this is all about what? Periodic table. That is especially modern periodic table. It is also called as longest form of the periodic table. Longest form of the periodic table. And another thing, students, you know, when the elements are discovered, they assign the name based on the countries who discovered, okay, and the scientists who discovered. Based on them, they try to name the elements. Correct? The element name, like iron is there, cobalt, lithium, sodium, they are how the names are arranged either by the which scientist discovered the respective element, that name is assigned. For example, at the same time, two scientists, two nations, Soviet Russia, no? Soviet Russia, and also America. Sorry, Russia. Okay, America and Russia. Both are discovered the element with 114 same time. Okay, so at that time what happens? They don't know to which country the element name should be named. So 114 element is discovered by what? Russia also, America also. Okay, na? So there is a confusion in naming the element with this or this. And the scientist who discovered that is Rutherfordium. Rutherford. Okay, is the scientist of America who discovered the element 114. So later the properties of the elements is studied. So this Rutherford successfully explained the properties of 114 elements than this Russian scientist. Understand? So that's why the 114 elements is named as Rutherfordium as a scientist name. As a name of the scientist which were discovered by them. Okay? Understand? So 114th element is simultaneously discovered by Russia and America. So there is the dilemma in the arrangement of the name of the element. So then what he did? The Rutherford, the American scientist, successfully explained the properties of element 114. So it is later named as Rutherfordium. The element 114. The name of the element is Rutherfordium, discovered by the scientist Rutherford, American scientist. So to overcome this type of dilemmas, so they suggested how to write the name of the elements with number greater than atomic number greater than 100. So listen here, 0 is there, 1 right here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Call them as will, by, try, by, bend, accept, not, and the last one is okay. So it is symbol N, it is symbol U, it is B, it is T, it is Q, P, H, S, O, E. Okay, students. So listen, how to write the name of the elements and start from 101. Okay, as I told you, It is greater than 1 means 101, 102, 103, 4, 5, 6, 7, 8, 9, 110. Next 11, 12, 13, 14, 15, 16, 17, 180. Okay, so how to write the name? So listen, 1 means here UN is there. Correct? 0 means NIL is there. Again 1 means UN is there. And last we have to add IUM. Okay? UN, NIL, UM. Last IUM after the completion of the name of the particular digits. Understand? So next 102. 1 means 1. This one is nil. This one is by. So already I is there. You are just UM. Understand? So for this, try UM. Okay. Next, 0 means nil. This is try UM. Okay. Just the simple names. This one. Okay. 1 means nil, 0 means nil, 4 is there, that is square. We have to add IUM. Okay. Similarly, here I write. Here it is UN. Here it is UN. 4 means square, ends with IUM. Here we have to take this is this one 8 means what? IUM. Okay. So how to write the symbol? Last I represented the symbol, right? The symbol of 101, the element, like sodium, you are going to write here, right? Similarly, for this, U, N, U. The symbols last I given U, N, U. This one is U, N, B. This one is U, N, T. This is U, N, Q. Understand? So that is a symbol what I wrote there. So like that, this is the way to name the elements with the atomic number greater than 100. Okay, so to overcome the dilemma of assigning the name, so they suggested this unique character to name the elements with greater than 100. So students, later assume there is a element with atomic number 122 that is not yet discovered, but we can able to write the name of this 122 element by using these terms. Understand? So this is all about the modern periodic table. In the next class, we will discuss about the classification of the elements in different blocks, what is their general properties, their general configuration, everything. Okay? Thank you.